In this video, we will be talking about triangle proportionality theorems. There are two of them that we will talk about. The first one states, if there is a line that is parallel to one side of a triangle and intersects the other two sides of the triangle in two distinct points, then it divides the two sides proportionally. So what this is basically saying is that if you have a line in the middle of our triangle, or somewhere inside the triangle that is parallel to one of the sides of the triangle, you are creating proportional parts within this triangle. Okay. So we are going to be writing proportions of different parts or sides of the triangle based on what we're given. Okay. So one thing to remember is that you need to be consistent with your ratios. So you should be asking yourself, are you comparing sides of a triangle or parts of the side? So an example of that would be AB here can be thought of as a full side in this smaller triangle that we have. Okay. So that is a full side. Now, if you look at BC, BC can be seen as a part of a side because this is not a triangle, right? But it is part of the full side of the larger triangle. So that would be part of a side. All right. So AF over FE. So let's take a look at what we have here. AF, you can see, would be kind of the side of a triangle, the top part. FE would be a part of the side. So we want to find something that's also the same. So another example would be AB, right, to FE, or to BC. So AB to BC. Okay. Another ratio we can write for the same one, AF over FE, would be this down here. So you can see that this is part of our smaller triangle. It's a part of the side. And then we have a part that is just a part of the side again. So we have AG over GD. Okay. We'll be marking all these different sides that we have. Alright, so AB, again, looking at AB for this one here, AB over BG. AD over BG. So looking at this, we have a full side of the smaller triangle, and we have part of the side of the smaller triangle here. So let's mirror that with the bigger triangle. So we have the full side with the bigger triangle and part of a side of the bigger triangle. Okay. So that would be AC over CD. AC over CD. All right. FB over EC, so let's mark those. FB over EC. So again, asking yourself, are they comparing sides of a triangle or parts of a side? FB here is the whole bottom part of the smaller triangle, so this is a side of the triangle, and EC is also a side of the triangle. So let's compare the sides of the triangle of the smaller triangle with the bigger triangle. So AF is the side of a smaller triangle, AE is the side of the bigger triangle, so it would be AF over AE. Another option you can have is AB comparing to AC. Finally, BC to FE, right? So you can see that BC is part of a triangle, and FE is also part of a triangle. Okay, on the other side. So another two sides you can compare would be maybe the other part. So AB to AF. AB to AF. It takes a little bit of time to see what's given, but usually in problems we will the parts will be given to you, and you'll need to know which proportions you can set up with the problems. Okay, we'll do one here as an example. So first one, we have to state that EC has to be parallel to AB, so that we can use this proportionality theorem. So since these are parallel, now I can set up each side that are proportional to each other. Okay. So what's kind of nice is it's already in a proportion for you. So you can actually set up a proportion 8/16, like it's in a ratio, equals 12/x. Okay. 8/16 equals 12/x. It's kind of already in the same format. So let's go ahead and cross multiply, and let's see. 8x equals 12 times 16, 192, and we divide by 8 to get x equals 24. And the proportions, you can see that is pretty accurate. We have 8 to 16, so that's doubling. So if we double 12, we should get 24.